So today, we're going to do this activity, and we're actually going to derive R squared. Remember how I talked to you last class about the sentence that you should be using for R squared? And you should have done that on your scatter plot investigative task as well. Next to your R squared, I was looking for that sentence, okay, on each of those. So I have created this kind of little thing that we're going to go together with, and I'm not really sure why, but I don't have the template up on the smartboard. I did, but it somehow didn't get saved to my OneDrive teacher problems, okay? Anyway, so you have it in front of you. I will also put a copy of this up on School Fusion, so if you're listening to this, hoping that the video actually works today, you'll be able to follow along, print out your own copy, okay? So what I want to do here is I want to reward, I'm just going to read the first sentence here. It says, Mrs. Macker is rewarding her students with a candy grab, and I want to be able to predict how many pieces of candy each student's going to grab, okay? So I'm looking at how much candy do I need to buy, like how much did I need to put in that bowl. So I'd like for you guys to take a little, well, I should have had you do this before, but estimate, you already know how many you grabbed because you've already done it. So just tell me how many you grabbed. Look at number 2 and write the number that you grabbed personally in number 2. Would have been nice to estimate it before you grabbed it. You're going to need your own pencil because we're going to be writing a, okay. All right, good. So you wrote down the number you have. Okay. What we're going to do is we're going to put those numbers in our calculator. So we're going to go to Stat Edit, and if you're going to do this along with me, and again, we're going to be doing some things today that you wouldn't normally do. So what we did here is not necessarily what I need for you to do on your investigative task, what you turned into me today. Do you have your investigative task? Okay, I'll take that too. But it's going to be just the derivation of the R squared number, okay? So what is R squared? What is it measuring? That's what we're going to be looking at today. So what I'd like us to do is we're going to go around the room, and we're going to put the numbers in. Can you put them in your calculator as I do as well, okay? Yes. Oh, yeah, Josh. Candy hog. Come on, pass it along. Thank you. I'll save it for you, baby. All right, so let's start with Josh in the back there, and tell me how many pieces of candy did you grab? 31. So 31, enter. So you enter as I enter, okay? 21. We're going to kind of go around. Matthew? 32. Ricardo? Shh. 28. Fernando? 31. Samantha? 18. Okay. Jessica? 11. Anna? 23. Elena? 19. Katie? 19. Esmeralda? 14. Jenna? 23. Catherine? 19. Okay. Ayana? 21. Lexi? 25. Cameron? 14. Maria? 19. Karen? 7. Oh, yeah. 14 was you? 19. 7, okay. 17. 31. 40. It's all right. I had a student in my second block class that grabbed 54. Marcel. Oh, I knew it. Okay. He was like, rah! He was like the claw, you know, like that. Okay. Anyway. So we have our data, and so these are the number of candies you guys grabbed. I want to be able to predict how many candies on average we're going to have to find. So how would I take this information and find a value that would be a good estimate? How could I estimate on average how many people are going to have? Take the average. I tried to say it a couple of times so you would get that hint. What is the average of this data? How would I do it? Stat, calc, 1var stats. So our average is 22.05. let's actually be, so we'll say 22.05 is our average. Okay. Now, these are numbers you need to write down, and as we go through, I believe this is going to be number 4. How could you use the data? So the answer to number 4 would be the average. So you're going to write the word average. And in number 5, you're actually going to write the value 22.05. Okay? Okay. Number 6, we have to think about this one. It says, does this model, the model being the average model, okay, does it predict correctly the number of starbursts every student's going to grab? No, there's going to be some errors. I mean, not everybody grabbed 22 starbursts, right? I mean, we had Karen who grabbed 7, right? There's some errors there. Well, she's not an error, just based on her hand size and her grab. I mean, I'm just saying, like, it has nothing to do with her, but it's errors from the model, okay? That's what I mean when I say errors. The difference between each student and the model. So what we need to do is do a calculation. And we're going to call it the SST, and it's not something that you've necessarily done in its entirety, but you've done some of it. So let me explain what it says. It says we're going to calculate the sum of the squared errors. All right, so we have technology, so let's use it. If I go to Stat Edit, and when I talk about errors, I'm talking about, oh, I'm sorry, the difference between the value and the mean. How far away from the mean I am. Okay? So what I'm going to do over here in list 2 is I'm going to find the difference between each of those values and the mean. So I've gone and highlighted L2, right? Okay. So what am I going to tell the calculator? I'm going to tell the calculator to take everything from list 1, and I'm going to subtract 22.05 from it. Good. Oops, excuse me. But hang on. It says the squared errors. So I'm going to square these values. So hang on. So I'm going to go ahead and just make sure that I'm squaring them. So I'm going to insert a parentheses around it. And I'm going to square it. So those are the squared errors. I've subtracted the average or the mean from each of those values, and I've squared it. This looks sort of familiar to me. Does it to you? It's very close to standard deviation. It's on our way to the standard deviation. Didn't we do this before at the very beginning of the year? It was part of our standard deviation calculation. Okay? All right, so I'm going to press enter to populate those numbers. Okay? Okay. Numbers are kind of big. Because that means that some of them are big, some of them are not so big, but that just means that some people grabbed a lot more or a lot less than 22. That's okay. Bless you. Now, it does say that the SST is the sum of those values, right? So I need to sum them. Do you remember where the sum is? I'm going to quit to get a blank screen. Where's the sum? Anyone remember? Well, you could do that, but if you just go to the second list and go over to math, sum is there, option 5. But you're right, Catherine, that sigma does mean sum also. And I wonder if I couldn't do that too. But I'm going to do it here. That's actually a good thought. All right, so I'm going to choose option 5. What list am I summing? List 2, okay? So I have 1,200, and so the sum, or the SST we're calling it, is 1,266.9525. And we'll need that later. Nope. This is just the derivation of R squared. This number is part of the calculation. All right, let's turn it over. Let's look at number 7. Everyone okay so far? You sure? All right. I want us to think about why this model alone is not a good predictor. Why isn't 22 a good predictor for the number of starbursts that someone could grab out of the bowl? there's different, there could be outliers, but keep talking. What other issues could there be? Why could some people grab more than others? Hand size. Wouldn't you agree? So hand size is something larger-handed people, I would think, I don't know, but I think larger-handed people might be able to grab more starbursts. So why don't we do this? Why don't we measure our hand spans and add that variable to our list, okay? So you need to measure it, and we're going to use centimeters just to be consistent. I'll hand out rulers here in a minute. And we're going to measure it, and then we're going to put that data. Well, actually, we don't need this list anymore, so I'm going to clear out list 2. Once I found the sum, I'm fine. We're going to put our hand size in list 2, okay? It's going to be important as we enter this data that your hand size is matched to the number that you personally grabbed, right? You have to be matched. So we have to make sure that when we go here that we go in the same order. So Josh, you were 31, right? So what was your hand size, babe? Just 20 exactly? Okay. 21. Is that you? Okay. 19.5. Okay, next. Where'd I go? Ricardo, were you 32? No, Matthew. Okay, go ahead. 23. Okay, who was 28? Okay. 19. Okay. 31. 20. 18. 17.1. Make sure you're entering this as we go along, folks, on your calculators. Who had 11? Okay, 19. 23. 21 point what, baby? 21.3. Who had the 19? 19.4. Okay, 19. 18. 14. 17.4. Okay, 12. Oh, I'm sorry, for 23. 20.5. Hey, Miss Nails. 20.5. 21. 22. 25. 20. 14. 19.5. Oh, not 195. 19.5. 19. Maria, do you have 19? 19.5. 7. 16. Teeny hands. 16 and a half. 31. 20. And 40. 24. We got Mr. Big Hands. Okay. So we've matched our data. And I want to just see what the graph looks like. I'm hoping it's linear. But before I do, I have to think about something. Which one of these is the explanatory variable, or the x? Which one is the response variable, or the y? What depends on what? Hand size depends on the number that you grab. No. Other way around. The number that you grab depends on your hand size. Would you agree with that? So we kind of listed them backwards. Would you agree? So we have to just pay attention to that. When we graph it, we're going to do L1 is our y variable, and L2 is our x variable. Okay? So just make sure you understand that we're paying attention to that. All right, so I'm going to go to my y equals, or my stat plot. I'm going to turn it on. Where'd my x's come from again? List 2, because that was my hand size. And my y list is the number I grabbed, which I entered in list 1. Okay. There we go. I just want to make sure my y equals, I don't have any equations. I don't. Again, we're going from list 2 to list 1, because we switched our x and our y's. They're in the wrong list. Oh, because they think it's a flex. It's not. All right, we're going to zoom stat just to get a picture. What do you think? If I was going to describe the distribution, what would you say? Positive? Linear? Moderate? I don't know. You can't really know until we put a correlation to it. Would you agree? Got to have that number. But I agree that it's pretty linear. It looks linear to me. Doesn't Byron make it real linear? Doesn't he strengthen our correlation? Okay. Yeah, and Matthew too, right? Actually, I think this is you. You're right. I think this is you. So it's Boris and Byron here. Interestingly enough, I don't see Karen. No, what I mean is that she's not unusual. Up top, girlfriend. Okay? She's aight. Okay? All right. She's aight. So what we want to do, I'm losing my mind today, y'all. Okay. On the back, we've gone ahead and we have found the new variable. We've put hand size on there. We've added the data. Now it says we want to build a regression model. So we're not going to do it with formulas because we have a calculator. We've already done the formula thing. Just remind, how do I find the line of best fit? Where do I go? How do I do that? Where do I get to LinReg? Stat, calc, 8. Good. Now, be careful. The default is list 1, list 2. But didn't we switch them? We have to tell the calculator that. So you're going to tell the calculator we're going to go from list 2 to list 1. Just backwards, that's all. L1, L2, L1. It's just because we put them in the list in the opposite order. We don't ever have to do that normally because the default is list 1, list 2, okay? But because we did them in backwards order, we're just telling the calculator that. That's all. And we're going to hit enter. All right. How's our correlation? Moderate. Right. All right. So let's write this. And so in number 9, we're going to build a regression model. And we did that. Let's put it in context as well. So what's our response variable again? Then what depends on what? Starburst. So the number of starbursts hat is equal to negative 35.07 plus 2.91. Would you agree with that? And then the variable is the hand size, hand span. Just running out of room, so I'm just going to write it sideways. Okay?
So what if we write it in context?
That is context. Starbursts and hands, when you put the names of the variables in there, that's the context.
What's the question, Chris? How would we write it?
Number D, or what are you pointing at? D is just, is it linear? You're going to say yes or no because of the SDF. Okay? So this is context right here. All right, so that's your answer to number 9. All right, now it says, using technology, a great old calculator here, it says to find the sum of the squared errors. Well, wait a minute. In a bivariate data set, what are the errors? In this bivariate data set, where are the errors? You found them on your scatterplot investigative task. The residuals. The residuals, because it's the distance from the point to the line, right? So that's how far away, that's the variability, those are the errors. So let's put our line on there first. Now, I can just type it into, didn't I round these though? I rounded these. I'm just going to be exact. If you want to put the rounded answers in, I'm okay with that. But if you're interested in knowing how to put the exact one in here, I'll show you real quick. If you go to VARs and go to statistics and over to equation, the regression equation will automatically put in there. If you're interested, if you want to put the rounded version because you have that written down, go for it. This is just a way to put the unrounded. It will put in the most recent regression that you did. We just did one. You go to VARs, statistics, equation. Or I think it's equation, yeah. And the option 1 is the regression, if you're interested. Okay. And so if I hit graph now, it should graph our line of best fit. Looks pretty. Not too bad. Someone's on the line. Who dat be? I love you. All right. Who would that be? I don't know. All right, so we're looking for the residuals. We're looking for these errors. So we have to remind ourselves how we put the errors in. So we're going to go back to stat. What did I do in my table before? Do you remember? Now, I can't just go and use the residuals and have them put it in here because I put these in backwards, remember? So it's going to mess that automatic regression fill in for us. It's going to mess that up for us. So we kind of have to put the equation in here, okay? So the equation is going to be, what, negative 35.07 plus, what was it, 2.91? 2.91 times the handspan, which was where on our list? List 2. Good. Because list 2 is where we put our handspans, right? So these are going to be all the question? This is not the residuals yet. This is just the predicted values. Huh? I'm going to hit enter. They're flipped, remember? List 1 is flipped. We switched them because our variables are backwards in this example. All right. And that's just a predicted. To find the residuals, I do my observed minus the predicted. And where are our observed y values? L1 in this case. So our observed values minus our predicted values, which are in L3, these are going to be our residuals. Okay? And hit enter. Some are positive, some are negative. Okay. Yeah, I'll scroll down a minute. Now, if I keep reading, and again, you're never going to have to redo this. This is just kind of a derivation of the R squared. But if you look at it, it says the sum of the squared errors. List 4 is just the errors right now. Don't I have to square them? Yeah. So let's do that, okay? That's what I'm going to do. But let me go down and help me show Byron what he is. What is Byron's residual? Byron's residual is, where are you, Byron? Oh, your residual is only 5. You're close to the line of best fit. You're just far out, that's all. So your residual is not that far, right? You're not that far away from the line. Okay. You did strengthen it, didn't you? Okay. So if I go to list 5, that's what Esmeralda suggests, and I agree with her, I just want to square the residuals. So where do I go to do that? L5, I just want to take L4, maybe. L4. Why aren't you doing it? L4. Oh, because my smartboard's not working. Which is probably why the recording's not going to work if it doesn't work. We need a new VGA cord on this computer bad. All right, let's try it again. So we're going to take this L4, and we're going to square those values. All right. Now I want to sum them, right? We want to sum the squares. That's what it told me to do. I found the errors, I squared them, and now I'm going to sum them. So I'm going to find the sum of list 5. Okay? So where was sum again? It actually is list math 5. So the sum of list 5, 599.49. And we're going to call that the SSE. So I have the sum of the squared errors of the univariate data set, the sum of the squared errors on the bivariate data set, and now I'm going to do a calculation. It tells you if you look at number 11, it tells you to find the difference of those. So we're going to take the SST minus the SSE. Oh, it doesn't let me do that. Interesting. You can go ahead on your OS and grab it, but I can't do it on mine. Make sure I did that right. Nope. 599.49. There we go. And so the difference is 667.4625. So on question number 11, we have this. But in number 12, it tells us to take that difference and divide it by the SST again. So I'm going to take this, I'm going to divide it by 1,266.9525 to get the answer for number 12. So I'm going to divide this by 1,266.9525. And I get, for number 12, 0.527. About 3 decimal places is probably the best place to go here. Nope, not, well, yes. You got it. You know what you're doing. You did? Okay. So it's it is an error percentage, which explains the variability of one variable in terms of the other. So what you're going to do here is we're actually going to go ahead and go back to our stat calc and our lin reg, and I want you to tell me, what do you notice is the same number here? It's r squared. We just calculated by hand r squared. Hello? Never going to ask you to do that again. Okay? But I wanted you to understand where it comes from. It's an actual value. It's a number. It has meaning. It comes from something. Okay? So let's write a sentence that you should have done anyway on your scatter plot investigative tasks in context for, yes. So on number 14 on your sheet, I want us to write a sentence. So we're going to say, because we have to change it to a percent, Katie's right, so 52.7% of the variability in, now, we're looking for our y variable here, or our response variable, and that's going to be the number of starbursts. So the variability in the number of starbursts can be explained by what? Hand span. Good. Hand size, hand span, whatever. Now, on your scatter plot investigative tasks, there were no contextual variables. They were just y's and x's. So you would have put y here, and you would have put x here. Okay, but if there ever are, there is context added. Now, obviously, that number changes depending. Okay? How do you feel? Right? You guys have we call it, and so I'm part of this AP Stats group and all across the country. It's for a bunch of nerds, and I love it, but that's okay. So we have this website that we use to share information and whatever. And so one of the actually, he's a college professor. His name is Jared Dirksen, and he actually writes a lot of the statistics textbooks. But he has this thing, and he calls all of his free response questions frappies, like a frappuccino, because FR, but I'm not really sure why the Q comes in. So I really don't understand what frappy means, to be honest with you. But it's FRQ, okay? It's a free response question from a test. That's really what we're going to call it. And this is the one that goes with bivariate data. So it is a release question. What I like about his format, and I'm stealing, is that he already has the EP and I next to each part. So when we go through the grading process, we'll be able to just circle it and be able to grade it right away, okay? So just the format. So what I want you to do is I'm going to pause the recording here. I'd like for you to go ahead and look at this. Notice you do have a computer printout. Make sure that you're circling what the numbers mean, which one is the y-intercept, which one is the slope, which one is the r. You need to remember that because you will see that again. So I want you to go from there. So I'm going to pause the recording, and I want you to go ahead and work on the frappy. So this question, I've gone ahead and copied and pasted the scoring guidelines directly from the College Board's website to kind of see how well we can answer this question. So far, we have just about everything done with our bivariate data set unit. There is one more thing we're going to do. We're going to do that next week, and that's straightening out the data. And it's the last thing that we do with this unit. It's chapter 9, I believe, in the textbook. And so we'll do that next week, and then we're going to be done. So we'll do that hopefully Wednesday, spend a little bit of time on it. We're not going to spend a whole lot of time on it. And then we will test, I think I said next Friday, correct? That's kind of where we are at. Yes? What if you're not going to, we'll deal with that when we deal with it. I mean, everyone's not always going to be here, but do the best you can. All right, so on question 4, the thing that I don't like that they don't have is they don't have the hat on theirs, but you should be, and it should always be in context. If you guys forgot context, issue, okay? So don't change it, okay, because I want you to be authentic to what you initially put down, but you can go ahead and make some, some notes in the margin in a different color or something, but try to keep your original answer and grade your original answer, okay? So we had the predicted cost should be about 1,136 plus 14.67 times the number of passenger seats. Does that sound about right? Okay. They did this, and then they just wrote what the variables were over here. So you could have used y and x as long as you explained what y and x are. I think it's just as easy to put it in the equation. Okay, so either of those in context should have been there. I don't notice it doesn't have you use the formulas. So you could have just done what? Well, you have the numbers there, don't you? So you have in your computer output, the numbers were given to you. So really all part A is doing is having you know what the computer output is, right? That's all it's asking you to do. Remember, in the computer output, you have the 1,136. It's underneath the coefficient next to constant. That's your y-intercept. And the number right under that is your slope. Okay? All right. So these are just the solutions. We'll get to how they graded them soon. Part B, you were looking at trying to find the value of r. It is the square root of r squared. Again, r squared is provided to you in the computer printout, 0.57. So you get 0.755. It asks you to interpret it. So we're looking for moderate. I don't think I would have go with strong, but they said they would have accepted strong, which I find is not so great. Okay, moderate, positive, linear. How did we do? Did you use linear? Did you use the words? Hopefully you did. They said that you could have written the r. They would have accepted the interpretation of r squared in context here as well, which I thought was interesting. It's probably going to be a deduction, and we'll explain what that means. I don't know. I don't know what it will be. We're going to go. This is just the solution, so we'll get with the EP and I in a minute. It's okay. This all will be online. Okay. I'm going to have to stop this so I can make a video here. I'll make our video in just a minute. All right. Part C, the answer was no. Okay. Because it asks you here. I'm sorry. I'll read it. I can't read upside down. It says, does the line shown in the scatter plot provide the best description for the data in this particular range from 250 to 350? And the answer is no, because the line is influenced by the 3 points on the upper right-hand corner, right? So because of that, which is outside of that data range, if those 3 points weren't there, it would be a different looking line. Okay? So that's, if you actually take those 3 points away, the regression actually becomes negative. Did you notice that? If you take these 3 points away, the regression now becomes negative. So it totally makes from a positive to a negative situation. Okay? So yes, that's a problem. Okay? So let's see how they scored it. They were looking for 4 parts, EPs and Is, a total of 4 points. I think we're missing something here. We should have 4 EPs and Is. I'm not really sure why there's only 3 on your sheet, so we'll figure that out. The correct equation is going to be an EP or an I, the value of the correlation, interpretation of the correlation. So for part B, there should be 2 EPs and Is, okay? And go here. Well, maybe not. We'll see. Element, no, I'm wrong. Element 1. So correct equation, and the variables are defined. Give yourself an EP or an I. Did you do that right? If you forgot the context, it's a P. Partially correct if you wrote the equation without context. Are we okay with E, P's, and I's? Who has what? All right. Element 2, all you had to do is tell me the correlation. So again, you should have 2 E, P's, and I's underneath letter B. There should be 2 of them. You with me? So write another E, P, and I next to number 2, or next to B. The first one is if you just tell me the correlation is 0.755. Most of us should have gotten that, right? E. The next question, again for part B, is the interpretation of R. Okay? So, the interpretation of the description. We're looking at strength, direction, context, and linear. So, and they could have done R squared. So again, you had to say linear, moderate, positive. Thank you. I'm like, I know there's another one missing a word. Okay? So let's see what partial would be. Partial would be 2 of the following. If you forgot the word linear, you got a P. Strength, direction, form. Do you see why I'm telling you these acronyms to help you remember all of the pieces? Okay, I'm hoping that helps you get everything you need. E or a P? Doing good so far? Let's look at the last part. I think the last part was the hardest part. It's part C here. It's essentially correct if you state the line is not a good fit and explains that it would make it negative. So you needed to be able to say both of those things. So you had to say the word no, and that if you omitted those points, it would make it a negative line. If you only said no, hang on. If you only said no, it's an I, because you had to say the explanation to get a P. Because it doesn't say that it makes a line negative, I don't think that's correct. Okay? So how'd you do? Would you get a 1, 2, 3, or 4? Let's look. If you had E, all 4 of E's is a 4. If you had 3 E's and anything, I, P, anything, could be an I or a P, it'd be a 3. 2 E's is a 2. And again, I don't care what the last ones are, IP, IP. And then 1 element correct. So basically, you're just counting the number of E's you had. Okay? How many of us, anyone get a 4 by chance? How many of us got 3? I'm expecting some 3s. Raise your hand high, be proud. How many got 2s? All right? Do we understand where we made our error? No. A 2 on the question is not a 2 on the exam score. A 2 on a question is not terrible, actually. It could help or hurt. I mean, it could help your score. Oh no. I'm still recording. Okay, good. Your homework is going to be in chapter 8. If you are absent, you also need to do the Frappy. I will put it online, which is this free response question from from 2002. Number 4. No, you keep it. So you need to do that if you didn't. If you're absent, that is part of your homework. But in chapter 8, the homework that you have to do are the following problems, and it is due Wednesday, regardless of your PSAT status. So it's these problems. Okay?